Well, hello and welcome to this exercise on the equations of lines inequalities domain range. Now, the way the equation is set up here is suitable for iGCSE, GCSE, and 10th grade maths, and also for AS level and additional mathematics. Okay, I should explain it wrong. Now, this is a diagram given to us here. Now, for iGCSE, GCSE, and for 10th grade mathematics, you may or may not have this grid here. Yes? Okay? You may or may not have the grid, or you may be given just the coordinates of the points there, and the point there. For AS level mathematics and for additional mathematics, this grid will not be there. You will only be given the coordinates of the points there, the point there, and the point there. Okay? So that's the main difference. For AS level and additional mathematics, there'll be no grid there. Okay, now here's a question. It says AB and BC are adjacent lines, and it says find the equations and inequalities that define these lines. In other words, whatever your answer is, this line must not extend beyond A nor beyond B. And also for this line here, the line will not extend beyond B and beyond C. So in effect, it's restricted between B and C there and between A and B there. Okay. Now, obviously, to find the equations of a line, you need a gradient. Now, if you did iGCSE or GCSE or 10th grade, you can find the gradient by doing the rise divided by the run there, and that's going to be negative slope there. And for that, we're going to have the rise divided by the run there. So that's easy enough. But I should try and do both, with or without the grid. Right. Now, the coordinate of A is 2, 2, and the coordinate of B is 8, 0, and the coordinate of C is 6 minus 6 there. You'll be given this in A level, or even for iGCSE. Now, to find the gradient, you do y1 minus y2 divided by x1 over x2, and that's what you got there. So you got 0 minus 2 divided by 8 minus 2 there, and minus 2 over 6 will give us the same as minus 1 over 3. So we've now got the gradient. We've now got the gradient for AB, that one there. So we now have to try and find the value for C, because we know that the equation of a straight line is y is equal to mx plus c there. Okay. Now in this case here, if you look at the point B, B has got the coordinate 0, 8. So y is 0 and x is 8 there. So 0 is equal to minus 1 over 3 times 8 plus c there. If we then add 8 over 3 to both sides, that will cancel out. So we end up with c is equal to 8 over 3. Now, we can now form our equation. So we end up with this here, that y is equal to minus 1 over 3 x plus 8 over 3 there. Now, if we left it at that, the line produced by this equation is going to go beyond A and beyond B. So we need to restrict the length of this line here. Okay, so here we go. So the x values for this line will be x is less than 8 and greater than or equal to 2. So x is less than 8 and greater than or equal to 2 there. So anywhere there, the x values will be valid. Okay, now that's called the domain. Now, if that were in the exam, you can stop there if you want to, but so you can also do another what's called the range, and the range for the line AB is that y is less than 2. Okay, y is less than 2 there and greater than 0. So y is there. Okay, so that's the range there. That will give you the y values for which that are valid for this line here. Okay, now any of this will be suitable for this question here. You don't have to do both, but any of this will be okay. Because if you got a graphic calculator, for instance, if you put in your equation and put in domain, you get this line there. You don't have to do both, unless you're asked to do that. Okay, so that's for line AB. Now for line BC, now you can find the gradient by doing your rise divided by the run there. But for AS level mathematics, you may not be given this the gradient of C there, because we know that AB and BC are adjacent lines of a rectangle. So the angle ABC must be right angle there. And if two lines meet a triangle, then the product of the gradients will give you -1. So, you know what, if you do -1/3, which is the gradient of AB, times m sub BC, which is the gradient of BC there, you get -1 there. So we then give it that m sub BC is equal to 3 there. So now, having found the gradient for BC, we can now find the equation for BC. But firstly, we need to find the value of C there. Okay, now using B as a reference point again, so we have that 0 is equal to 3 times 8, because y is 0 there to give us y there. Oops. Okay, and x is 8 there to give us an 8 there, and the m value is 3 there. So 8 times 3 is 24. Now, so C is going to be -24. If you add 24, if you subtract 24 both sides, you get C is equal to -24 there. Now we can now form the equation for BC. Okay, so BC is going to be y is equal to 3x, 3 because 3 is the gradient and x is there, -24 there, which is the value of C there. And as before, if you left it at that, your line would extend beyond B and beyond C. So you need to put in the restrictions there. Okay, so for our domain first, the values for x, we have that x will be less than 8 and greater than 6. So x will be less than 8 this way and greater than 6 this way there. Yeah. Right. And that will be our domain there. Now for a range, we have that y is greater than or equal to -6 and less than or equal to 0. So y is going to be greater than -6. That will be this way, going up that way, and less than or equal to 0, going down this way there. Okay. Now, if you let it at that, your line will go beyond B and beyond C. Now, this will add restrictions to the length of the line itself. Now, I hope all that made some sense. Please subscribe, and thank you for watching. Bye bye now.